One of the most common things that you'll need to do in game development is have one object talk to another object, whether it's your player talking to an NPC, or your weapon talking to its ammo, or maybe your input system telling some knight to move around. All objects need to be able to interact with other objects to make a game actually work. So today I'm going to cover some of the top ways to interact with other objects, some of the best ways to find and get the other objects so that you have a reference to them and you can interact with them. And I'll show you some interesting and cool tricks that I didn't learn until I'd been using Unity for quite a while. But before we get started, please hit that like button. It doesn't cost you anything and it really helps. If you like these technical videos where we dive into code, or you're just getting started with game development and want to learn more, hitting that like button makes a big difference. And if you have any questions about the content that I'm putting in here, or just comments or things that I might have missed that you think people should know about, drop those down below too. I try to read them all and reply to as many as possible. For this tutorial, we're going to use a scene with a bunch of knights in it. I've got 2 orange knights and 3 blue knights, and we want to be able to send these knights commands. And I want to be able to send specific knights commands at different times. So we're going to run through all of the different ways that we can get access to these knights, and then make them do what we want them to do. In my scene hierarchy, you can see my 5 knights. I've got an orange knight here with a knight script attached, a NavMeshAgent, and an animator so that it can perform some animations. The same for this other orange knight and the blue knight. They're all pretty much exact clones except for their visual representation. And up here I have a Finder example object with a Finder example script that we'll use to add in code to find objects and interact with them in a bunch of different ways. The first way that we'll interact with them is the simplest, which is just using a scene reference. Here you'll see that we have a toggle object field that takes a game object, and I can take one of my knights and just drag it right into that field. Now if I hit play, I should be able to toggle this orange knight on and off. Let's see it in action and then we'll take a look at the code. If I left click, my knight should disappear. You can see the game object actually turned off there. And if I right click, he should reappear. Let's stop playing and take a look at that script now. I'll open up my Finder example and you can see here on line 5, we have a serialized field for a game object for our toggle object. And this is the field that's showing up in the inspector. We could alternatively have this be a public field, but if you've watched any of my other videos, you probably know that making it public isn't the best option if serialized field will work. Go with serialized field by default. That'll allow you to assign it in the inspector and not make it publicly accessible to be misused somewhere else. Once we've got our toggle object assigned though, in our update method, we just check to see if I've clicked the left mouse button with fire 1, or clicked the left control, or if I've clicked the right mouse button, which is fire 2. If I do left click, then we just call the GameObject.setActive method with false to turn the object off, and if I right click, we set it to true to turn the object back on. What if we want to access multiple objects at once though? One option is to convert our single serialized field into a list or array. Here I've set it up as a list of game objects. Let me expand out that toggleable object section now. And I'll assign my 2 orange knights by dragging them onto the toggle objects field. I'll take orange knight 1 and orange knight 2. Now if I hit play, I should be able to toggle both of those knights at the same time. Let's give it a try. I'll left click, they disappear, and I right click and they reappear. One cool trick here, by the way, is that I can hit the lock button and then go hold shift and select multiple knights, click and drag them over, and then add them all at once. This comes in really handy when you need to add a lot of objects to an array or list. Let's take a look at how this list works in code now. I'll open up my Finder example and you can see that I've changed my serialized field from a single game object to a list of game objects. This requires the using statement using system.collections.generic to allow for this generic collection of game objects, and a small change down here inside of my if statements. Instead of toggling a single object, I need to loop through all of my toggled objects. In fact, you can probably see that I've renamed this to make it plural by adding an S to the end of the field here. To deal with multiple objects, we need to change line 12 and 18 into being for each loops. A for each loop will iterate over each object in the collection or in that list or array, and then give us back a reference to it. I've named that reference toggle object, and then on line 13, we just call the setActive method on that toggle object. So the first time through, it'll toggle orange knight 1, then orange knight 2, then blue knight 1, blue knight 2, and then finally blue knight 3. Let's see it with all of the knights in action. So you hit play, left click, they disappear, right click, they reappear. Let's try removing Blue Knight 1 while we're playing. I'll hit the minus button, left click, everything but Blue Knight 1 disappears, right click, and they all reappear. Now let's call some other code. Instead of just toggling an object on and off, let's make one of them animate. Or in fact, let's make them all animate. I've got it set up now so that when I left click, all of my knights that are in my toggle object list will do a cheer. Let's remove the Blue Knight 1 and see if I can get just those 4 to cheer. There we go. Let's take a look at how this works. The first thing to note here is that we're still using a list of game objects. We haven't changed anything there. What we have changed is inside of our for each loop. Now instead of calling the toggle object's setActive method, we get an animator component from it, and then we tell it to set the cheer trigger on that animator. But what happens if we have an object that doesn't have an animator on it in our toggled objects collection? Let's take a look at the problem that might cause and then the solution to that. I'm going to take my environment, drag it over to be one of my toggled objects, and maybe put it somewhere near the middle, right after the 2 orange knights. We'll click play, and then I'll left click, and let's see what happens. So I left click and noticed that only the 2 orange guys played their cheer animation, and then we got an error. The characters after the environment in my list didn't play their animation. And if I double click on this error, I can see that it's right here on the animator's set trigger call. The problem is that the animator doesn't exist. So I need to be a little bit more opinionated about the type of objects that can be allowed into my toggled objects section. Let me show you how we can fix that. The easiest solution is to just change this list of game objects to a list of animator. That'll allow me to only put animators into this field. Now I don't need to call this var animator equals toggled object.getComponentInanimator. I can actually delete that line completely and just call toggle object.setTrigger. In this case though, I'd probably want to rename this to animator and then call animator set trigger. Again, the reason that this works like this is that these objects are no longer game object references, but they're animator references. So if I iterate through those, it's going to be able to just call the set trigger method on them directly without getting that animator component. Let's jump over to Unity now though and see what's happened to my toggle objects collection. You can see I've got my knights here with the environment and element 2. And now I have a type mismatch for all of them. I actually need to reassign them. This generally happens when you change the object type of any serialized field. The same thing happens if you make it public. There's no difference. You do need to reassign these. Let's go assign them now. I'm going to lock. Oh, I've actually got it locked perfectly. I'll go select the first knight here, hold shift, click on the last knight, and I'm going to drag these over to my toggled objects. Then I'm going to select these first set of knights and hit the minus button to remove them. Save the scene, and then let's take a look at the big difference that we've got here. I can now no longer assign my environment as a toggled object. I can only assign things that have an animator. In fact, if I clear all of these objects out, let's just hit minus and hit plus one more time. You see that it only takes animator objects. I can't take my Finder example and drop it on there. I can't drop my camera on there or anything else, only the valid knights that actually have an animator on them. Now let's take a look at something else we might want to do with our knights, like tell them to move around. Here I've changed our example to take NavMeshAgents instead of animators and made it so that when I click on a position in the world, my NavMeshAgents get that destination. Let's take a look at that code and see how it's set up. You can see here in my if check, we do another if check using a raycast. We check to see if the player has clicked into the world by using the camera.main.screenPointToRay method, which just generates a ray directly into the world underneath the cursor, looking for an object that we hit. We're not checking against layers, so technically we could click anywhere, and if it's not on a nav mesh, it's not going to work. But if it is on a nav mesh, what we're going to do is loop through each of our NavMeshAgents and call the setDestination method on that NavMeshAgent. Now technically, we'll call that even if they click off of a nav mesh, but if the point's not valid, it just won't do anything. Let's take a real quick look at the knights and the NavMesh setup, just in case you're not familiar with those. Each of the knights has a NavMeshAgent added onto it, which is just a built-in Unity component. And then we have a navigation mesh baked, which you can do under Window, and then AI and Navigation. Any objects that are marked as navigation static will get marked in as bakeable and bake in with this little blue outline. The blue outline shows where my navigation mesh is and where my characters are able to walk. To toggle walkability for a specific piece of terrain, you can just select that object or the entire terrain, go to the object section of navigation and uncheck or check navigation static, or even use the navigation area section. Now let's move on to something a little bit more advanced. What do we do if we want our knight to both move and cheer? Well, in general, in a game, our NPCs are probably going to do more than one thing, and we don't want to be referencing them by individual components, at least not very often. In this case, what I would like to do is build a knight class, and then reference that single knight class and have it do multiple things. That way I only need one reference to it, I know that it's the right object, and it can do all of the things that a knight needs to do. Here I've set it up with multiple knights and my blue knights assigned. I'm going to left click, they'll move, and if I right click, they'll start to cheer. If I left click over here, they'll move again, and I right click and they start to cheer. Let's take a look at how this works. The first thing to note on our Finder example is that we're now referencing a type of knight. Instead of a NavMeshAgent or an animator, we're using a knight. If I clear out all of these knights, you'll see that I can hit the plus and it will only allow a knight in there. If I take my environment, again, it won't allow something invalid, but I can take my two orange knights and drop them in. Let's see, drop number 1 and drop number 2 right on top of the word knights. It'll add to that list. Now, how did I limit it to my specific knight? So first, let's take a look at the knight. If I unlock my inspector and scroll down here below my NavMeshAgent, I have this knight script on it. Let's take a look at the knight script and see how it works. The first and most important parts are on line 6 and 7, where we have a reference to a NavMeshAgent and an animator. These aren't serialized fields, so they're not showing up in the inspector, and in fact they're filled out in line 12 and 13, or they're assigned by line 12 and 13 using a getComponent call. GetComponent is a method built into mono behaviors or built into any script that you can attach to a game object in Unity. The getComponent call will find another object or another component on that game object specifically that uses or matches that type. So here on line 12, we find the NavMeshAgent component, and we assign that to our reference that we have on line 6, this underscore NavMeshAgent. Now, the underscore part is completely mine. It's just a personal preference thing for my private fields. It is absolutely not necessary, and you'll see lots of examples that don't use that. It's just a personal preference on how I like to see and read my code. Now, caching the components is less of a personal preference and more of a general rule. If you're going to be accessing a component regularly, it's generally considered good practice to cache that in an awake method and have a reference to it so that you don't need to call getComponent multiple times. The reason for that is simply that calling getComponent too many times on too slow of a device can cause performance problems. You probably won't run into that for quite a while, so it's not something you need to worry about too much, but it is something to note. We're going to cache our components using the getComponent call, and then we can use them down below. Let's take a look at how these are used now. In my update method, I set my animator's walking bool to either true or false based on what my NavMeshAgent's velocity is. If it's greater than 0, it'll be true. If it's less than or equal to 0, the walk boolean will be set to false. That turns on and off my walk animation. We also have a move to method that takes a position that just tells our NavMeshAgent to set its destination to that position. We have a reset position method, which will reset the object right back to its starting position that we cache on line 14 in the awake, and then stop the NavMesh by calling the NavMeshAgent's reset path, or stop the NavMeshAgent technically. And then on line 27, we have a cheer method that calls the animator's set trigger passing in cheer to cause the cheer to happen. Let's go look at the Finder example and see how this is all actually hooked up. Back in the Finder example, you'll see that we've changed that list of NavMeshAgents to knights. And then in the loops on line 14 and 21, we loop through each knight and just call the methods that are public on that knight. The move to method that we've made public and the cheer method. This gives us access to both of those functions without needing to know about the internals of how a knight cheers or how a knight moves. This comes in really handy when you're building out your games and your classes, so I highly recommend that you build classes to wrap this type of functionality. What do you do if your game objects don't exist in the scene though? Maybe there's something that spawns over time, like my knights here spawning from a knight spawner. There are a lot of different ways that we can find objects like these knights at runtime, so let's take a look at them now. The first one in our Finder example is to use the FindObjectOfType method. Here you'll see that on line 11, we find all of the objects that are of the type knight. What this does is actually look through our scene and find every object with a knight component added to it. As we run, you can see that we're spawning knights and they all have that knight component added onto them. So this FindObjectOfType call will find every one of them and return back an array. Then we call the toList extension method on it to just convert them over to a list of knights. Now, you don't necessarily need to do this, but I thought it was an important thing to show. Another alternative way to do this would be to just store them in an array. We can remove the list and add in 2 square braces, which just means that we now want an array of knights. An array of knights is almost exactly like a list, except that we can't add and remove to it as easily. A list and an array are almost exactly alike, except a list is a little bit easier to add and remove things to. Since I don't need to add and remove things though, I'm going to get rid of this assignment to a list and improve our performance. Converting it to a list like that does actually make a complete copy of that collection, which isn't huge, but it can add up and it can take up some memory. Now, there are some other performance considerations here, like we don't want to necessarily be calling FindObjectOfType every frame in an update. That's generally a bad idea. It's not good for performance and it's unnecessary work. We only really need to keep track of knights when they're added. If we have a list that was active of all of the knights that exist, we could just use that instead of calling FindObjectOfType. Let's see one way that we could do that. Here I've changed the way this works. Instead of creating a new list of knights every update and finding them all every update, we've got a list that we create and initialize on line 6. Now we just need a way to add knights to this list as they're spawned. The simplest way to do that would be inside the knight spawner. When we create a knight, we could just find the example, find the list of knights on it, and then add our knight to it. Now this will work fine until we get to the point where one of our knights disappears. Maybe we've despawned him or he dies. Let's see what happens when I do that. I'll delete my blue knight and let's try to move and notice that we're getting an exception or an error. If I go to my Finder example, you'll see that it's because we've got this missing element here. We've deleted or destroyed a knight and we need to remove it from the list. The simplest solution to this is to just make our knights remove themselves from the list whenever they get disabled or destroyed, depending on what your use case is. Here I've hooked into our onDisable. I look for our Finder example script, find the knights list, and then remove this knight from that list whenever he's disabled. Let's go see what that looks like at runtime. I've got my Finder example selected there, and I'm going to lock the inspector to it. We'll hit play, and then I'll let a couple knights spawn, and then I'll delete a knight out of here, and watch what happens to the knight as I delete it. So we've got knights spawning. There's number 1, number 2, and then once number 3 spawns, I'll delete number 2. And look at that. He's removed himself from the list automatically, and I can still move my guys around without any errors. Now I want to show you a keyword that can simplify a lot of this code. We've been referencing objects by using the FindObjectOfType, but there are a lot of other ways to reference objects in Unity and C#. What we're going to use next is the static keyword, and here you can see I've changed my Finder example. It no longer keeps a list of the knights or has any way to find knights at all. Instead, on line 11 and line 18, we loop through an already existing collection called knight.allKnights. That's a static property on my knight class. Let's take a look at how that's implemented and how it works to give us all of the knights that are available. Here we have our knight class with our all knights list. Let's take a look at that list and see how this works. On line 12, we have public static read-only list of knights named all knights, and then it's initialized to a new list. There are a couple of interesting keywords here. First, it's public so that we can read this from other classes. Our Finder example is referencing our knight.allKnights. If we don't have that public keyword, we wouldn't be able to access that from there. The static keyword is a little bit different. The static keyword means that there's only one of this. There's only one list of all knights. Normally, when you add a field or a property, like our NavMeshAgent animator and starting position, to a mono behavior, it's what we call an instance field or an instance property. It's something that will be created for each instance of the night. So for every night that I spawn or place, it would have its own reference to its own NavMeshAgent, its own animator, and its own starting position that was cached. When we have the static keyword, though, it means that there's always just one of those. We don't create multiple, and we always just reference it in a single point in memory, which is one of the nice benefits. When we have a static field or a static property like this, we're actually just reading and writing or accessing directly to one spot of memory. I guess we're not technically reading and writing directly to it, but we're accessing it in that one spot, and we have a nice, easy way to reference it. The third keyword there is the read-only one, and that's not actually necessary for this. It just prevents the list of nights from being recreated or destroyed somewhere else. It doesn't, however, prevent us from adding or removing entries from the list. When I don't want to have my lists or collections recreated accidentally, though, it's a keyword that I like to just add on there because it adds a little bit of extra safety. So how do we add and remove things to this list of all nights? Well, on line 13, we call the allnights.add and pass in our own instance. So we pass in the night that's been enabled. And on line 14, we just remove ourselves from that list. If you haven't seen this format, by the way, this is just an expression body method. It's the same as a normal method, just shortened down when you only have one line to call. You can write it like a little lambda, and it makes your code a little bit smaller. Now let's talk about another way to interact with and find objects in your scene. One that doesn't require you to write code or have a specific script for the objects that you want to find or get. And that's to use tags. Tags are actually a really powerful feature in Unity that allow you and your designers to essentially tag an item or a game object to be used by your code in some specific way. Say, for example, we want to make our gates light up when the player presses a button. And I don't want to write a specific gate code, and I also don't want to find things for all of the renderers because I've got lots of renderers in here. What could I do? Well, I could add a gate tag onto my gates. Here I've got one of my gates selected, and I'll just go to my tags and choose the gate tag that I've created. If you want to create your own tags, you just choose the tag option and then hit add tag. Make sure that your inspector is not locked, and then hit plus, type in the tag name, and hit save. That'll add a tag, and then you can use it from code. Let's see what it looks like to use that tag from code. Here you can see I've changed my Finder example so that when I left click or press Fire 1, I find all of the gates by using the GameObject.Find game objects with tag and passing in gate. You can see that on line 9. That'll actually return back an array of game objects. Then I loop through that array of game objects on line 10, and this is an important part. We need to get the component that I want to interact with. In this case, I want to interact with the renderer component of that gate. I know that my gates all have renderers on it, so I'm not being very safe. I'm assuming that I'm able to get that component, setting the materials color to red. So what do I do if I right click on line 16? I set the materials color to white. Exactly the same. Now, one thing that you could do to add a little bit of safety here is change this line up so that we assign the renderer and then check the renderer to make sure that it's not null. To do that, I'm going to add a semicolon here. I'm going to add a little bit up here. I'll say var renderer equals. And then on the next line, I'll say renderer.material.color equals color.red, but only if renderer is not equal to null. This will just double check that my gate actually has a renderer before trying to set the color on it. Because if I tried to set the color on something that's tagged as a gate that doesn't have a renderer on it in this loop, it would fail, break out of the loop, and not tint the rest of the objects. I should probably theoretically do the same down here on Fire 2, so I'll just copy that, paste it in, replace the red with white, which is again going to be probably the default color. If you look at your materials, when you're setting up a game object, it's usually slid all the way to white so that the colors match exactly and it's not tinted, just matching with your texture. All right, let's try that out and see what that looks like in game. So I press play and I should be able to left click, turn my gates or anything tagged as a gate red, and right click and it turns back white. Let's try just changing something else at runtime though. Let's maybe add this well, and instead of making it a well, let's pretend it's a gate. Go back to the game view, I left click, it turns red, I right click it white again. And if I stop playing, that tag gets unassigned. So you gotta make sure that if you're assigning tags that you want to keep on, you do that when you're not playing. Now I want to talk about one of the most commonly used ways to find game objects that I almost never use. I'll talk about why I don't use it, but first show how to use it. Here you'll see that I've changed up and added a start method. My start method is actually set up to work as a coroutine, just to show that you can do that, by returning an IEnumerator. That allows me to add in that yield wait for seconds on line 11 and have a little bit of a delay. On line 9, you'll see the code where we find the object, and I'm using the GameObject.Find method. That takes a game object by exact string name. The name has to match exactly. If I rename that night spawner object, it won't find it. The game object also has to be on. If that night spawner is not enabled or activated, it won't find it. So I have to turn it on in my scene, find the object here by name, and then on line 10, I turn the object off. After 5 seconds, I turn it on and we start spawning nights after 5 seconds. Let's go see that in action and see how it works. And then we'll talk a little bit about why I'm not such a big fan of it. So you can see I've got my night spawner here. I've got my finder example script running. I'll hit play, and after about 5 seconds, you should see that night spawner turn back off. It turned back on. It turned off right away. There we go. And now it turns back on. So why am I not a big fan of this? Well, one of the key reasons is that, say I add in, some square braces around my night spawner, or I name it night spawner 2 or anything else, and then I hit play. Let's see what happens. I get an exception, a null reference exception, because it couldn't find that object. Now, I could probably handle the null reference exception and make it a prettier log, but it's still something where I'd have to either go change the game object's name back or change the code to handle it. So that's one of the key reasons that I don't like it. The other problem that I have with it is that the game objects have to be active. So I have to make sure that I'm managing the state of those objects before we do a find on it, or that I'm defaulting things to being active and on all the time, because as soon as I change that up, it's no longer going to work. So in general, I would recommend not using GameObject.Find, but it can be handy if you really need to find a specific object by a specific name. It's kind of the easiest way to do exactly that problem, or solve exactly that problem. But it's probably a problem that you shouldn't get yourself into. One scenario that I do recommend you get yourself into, though, is separating out your logic from your visuals, and that'll change the way that you need to get components on occasion. Here I've modified my blue knight so that the visual part of the blue knight is actually a child. I have a knight model child underneath the actual character that I can turn on and off. That way I can swap out my visual at any time without changing my actual game object. The downside of this, however, is that my animator is no longer at the same level as my knight script. So if I use GetComponent, I'm not going to actually find the animator, because that only finds components on the same level on the same game object. There is, however, a nice easy way to get components in our children, and that's using the GetComponentInChildren method. There are two different methods that we could use here. There's GetComponentInChildren, which gets a singular instance of it, or GetComponentInChildren, which will get all of the components that match. So if I had multiple animators, I might want to get all of those animators. It's probably not something I would do. I'd be more likely to get all of the renderers or text objects or something else underneath there. It's very rare that I have multiple animators, but if I did, I would add in an S and use GetComponentInChildren. One thing to watch for is that it's easy to accidentally add or miss the S and then end up with an error and get a little bit confused. Just make sure that you have the plural or non-plural version based on what it is that you're looking for. That's 90% of the time the error that you run into. There's one more method that I want to call out, and that's the GetComponentInParent. This isn't one that I use very often, but it does exist if you need to look for something up the hierarchy. Here you can see that I've changed it and technically broken my code. But if you need to look up the hierarchy, that's a problem you run into. Just remember that that method actually exists. All right, I hope this has been helpful. If so, and you don't mind hitting that thumbs up button, I really appreciate it. Or subscribe so that you can learn more about Unity and game development. Or check out some of my courses down below or some of the other videos where I run you through the game development process, building a game from beginning to end. I've also got some free courses on that you can find down below as well. Again, thanks again for watching. Please, if you have a question, by the way, drop a comment. If there's something that I didn't cover or something that you're curious about in here with this referencing and just interacting with objects or just in Unity in general, drop a comment and let me know. All right, thanks again for watching.